Okay, so you start with the position function f of t equals t cubed minus 12t squared plus 36t when t is greater than or equal to 0. So here we're just finding the velocity function, which is the derivative of the position function, which is 3t squared minus 24t plus 36. And then it just asked for the velocity function when time is at 3 seconds. So you get -9, should be meters per second. And then finding a horizontal tangent, which is when the derivative equals 0 or the slope equals 0. So in that case, you end up with t equals 6 or t equals 2. And then in order to find when it's moving right, you first find the zeros, which are at 2 and 6, and then you find when the velocity is greater than 0. In that case, it's between when t is greater than or equal to 0 or less than 2, or when t is greater than 6 here. Or in between, no, this isn't right, shouldn't be there. And then in order to find the total distance, you do the absolute value of f of t minus f of 0, f of 2 minus f of 0, and you get 32, f of 6 minus f of 2, and you get 32, and then f of 8 minus f of 6, and you get 32, which all adds up to 96 meters. And then it asks for the acceleration function, which is just f double prime of t, and then f of double prime of t of 3, is -6. In order to find when it's speeding up, the velocity has to be greater than 0, and the acceleration has to be greater than 0, or vice versa. So they have to have the same sign. So I plugged in f of 3 into both of the equations, and they were both negative, so that shows that it was speeding up, just in the negative direction. And then here I plugged it in 8, and it came out positive, so therefore it's speeding up when t is greater than 2 or less than 4, and when t is greater than 6. That's it.